In this video, we will learn the final method of multiplying polynomials called the box method or the table method. We'll first see how this works just by multiplying two integers. If we were to multiply 15 and 18, we would represent 15 as 10 plus 5 and 18 as 10 plus 8. Then I'm basically just using the distributive property or multiplying horizontally as we had learned earlier, but in this box format. So in this box format, we would set it up by putting each term as a separate column or a separate row. It doesn't matter which one you put in the top here or which one you put on the side here. So now I would have to figure out the product of each set of the two numbers. If I were using the distributive property, I would multiply 10 times 10 to get 100, and I can do the same thing by looking at one column and one row at a time to find the products. Then you would have to combine like terms and simplify to get your final answer. This method can also be used for polynomials as well. We would set it up by putting each term as a separate column or a separate row. It doesn't matter which one you put as the row or which one you put as the column, but you're only going to put one term in for each box. So we could set up this problem here like this. Then we would have to figure out the product for the remaining four spaces, add up all the products, combine like terms, and write the final answer in standard form. This visual box method is related to the area model. Remember that to find the area of a rectangle, you have to multiply the length times the width. So in the area model, each rectangular section represents the area created by a portion of the length and a portion of the width. Once the areas of each individual section is found, then you can add them up all together to find the area of the entire rectangle. So if we wanted to find the area of this rectangle, what we'd have to do is our length, 2x plus 1, times our width, x plus 3. So to find the area of this smaller rectangle, we're going to multiply our length times our width. So x times 1 would just give me x. Moving on to then this next rectangle, I would do length times width. So 3 times 1 would give me 3. This bigger rectangle here has a width of x and a length of 2x, so multiplying those together I get 2x squared. And finally for this last rectangle I would end up getting the area of 6x. After combining like terms, the area of this entire green rectangle is going to be 2x squared plus 7x plus 3 square units, whatever the units are, inches, meters, whatever it was. Use the box method to find the area of each green rectangle. So the first thing I'm going to do is actually add the lines so that I can see very clearly the smaller rectangles that I'm going to find the areas of. So for this first rectangle, I have 2x times 5x, which will give me 10x squared. Then I have 4 times 5x, which will give me an area of 20x. Then I'll have 2x times 2, which will give me 4x, and finally 4 times 2, which will give me 8. Then since I have 4 green sections, I should end up having 4 different terms. However, because I have 2 terms that are like terms, the 20x and the 4x, once I combine them, I get my final answer written in standard form that the area of the entire green rectangle should be 10x squared plus 24x plus 8, and then whatever the units are squared. For this next one, I'm setting it up the same way by drawing my lines. So 7x times 2x will give me 14x squared. 2 times 2x is 4x. 7x times 1 will just be 7x, and then 2 times 1 is just 2. So then I'm just going to add up all 4 of those terms, and because I have 2 like terms, I can combine those to get my final answer in standard form as 14x squared plus 11x plus 2. Switching over to your notes packet, let's use the box method to find the product of these binomials. So when I'm writing out the box method, I typically like to do it kind of like a tic-tac-toe board. The main thing is just to make sure that you have room for those 4 spaces for you to write the products. So once I have all 4 of those products, those pink terms, I'm then going to add all of them up. And then I'm going to combine the like terms. Remember that the like terms are the variables raised to the same exponent. So that's negative 5y and negative 2y. So my final answer written in standard form is y squared minus 7y plus 10. For this next problem, I'm going to set it up the same way, creating a box. Once I've found all four products, I can then combine like terms to get my final answer written in standard form, r squared minus 6r minus 27. Setting up this one the same way, I'm going to put 3x minus 8 as one column or one row, and then x plus 7 as the other one. So then filling in my boxes as I go, 3x times x is going to be 3x squared, 3x times 7 is 21x, negative 8 times x is negative 8x, and then negative 8 times 7 is negative 56. So then I'll add up all four of those pink terms and combine like terms to get my final answer in standard form, 3x squared plus 13x minus 56. Okay, so for this next problem, please ignore that part that I crossed out there. We're just doing the binomial x plus 3 multiplied by that trinomial. So we haven't done this before, but basically, just like when we distributed, we just had to distribute to one more term when we were multiplying by a trinomial. So now when we have this box method, we just need to add one more row or one more column. So when I do x squared times x, I get x cubed. X squared times 3 is 3x squared. 5x times x is 5x squared. 5x times 3 is 15x. Negative 3 times x is negative 3x. And negative 3 times 9 is negative 9. So then from there, I'm going to add up all of those pink terms, but you'll have to be careful because now we have more than one set of like terms. So make sure that you're combining the ones that are the same variable raised to the same power. So that should be your final answer written in standard form. Try the next four problems by yourself and we'll go over the answers next class. Let me know what questions you have or what things you want to cover. Next class we'll learn about special cases when multiplying binomials.